Okay, so draw and label the forces, identify the net force, and draw the acceleration. Label your positive and negative directions. So these things you have to do. This is basically your knowns and unknowns in the diagram. Okay, so when you're doing these, you got a box applied with a force to the right. When you're doing these, the first thing you want to do is just label all the forces. I like to start with the y direction because I know there's always gravity in every problem. And the way I draw it is I start at the object and I draw in the direction of the force, so gravity is down, so I start at the object and I draw down. Okay? Once I've done that, then I think about, okay, is there anything against gravity? So there's usually two things against gravity. There's usually air resistance or drag, however you want to call it, and there's usually normal force. It's usually not both. It's usually one or the other. Drag is usually for falling, and normal force is for objects sitting on a surface. This is an object sitting on a surface. So I would draw an arrow up and write Fn for normal force. Okay, then I have an object with the applied force to the right. So I'm going to draw an arrow to the right, write Fa. It gives me the value for Fa. It says it's 7 newtons. And then there's a friction force in the opposite direction. Friction is always in the opposite direction. That value is 4. You'll notice I drew my friction force arrow a little smaller. I do that on purpose because it's less force. I make it smaller. I don't take off for that. If you don't make that arrow smaller, if you make it the same size, I'm not taking off for that. That's fine. Okay. Last thing is I do include the mass. I just write the mass on the object. And the mass of this is 3 kilograms. So that's step 1. Okay, step 1 is done. I drew the object, labeled the forces for the horizontal and the vertical. Okay. Okay, once I got that, then I'm going to identify the net force and draw the acceleration. So I'm looking for which direction is the change in motion, if there is one. So if there's no change in motion, all the forces will be balanced. The up and down forces are balanced, right, because the box isn't falling, and it's not getting launched in the air. So the up and down forces are balanced. Okay, so we're good there. And so then I just ask the side-to-side forces. Well, those are not balanced. I'm pushing more than friction is acting against me. Okay, so I am going to have an acceleration. Which direction is the acceleration? It's in the direction of the change. I'm going to change to the right because there's more force, right? So I draw an arrow for the acceleration. I usually draw it under or next to the object. I draw it under if it's going side to side. I draw it next to if it's going up and down. So this is going side to side. The change is to the right, so I'm going to draw an arrow to the right. I'm going to write A equals question mark because I don't know what the acceleration is. Didn't tell me. So I just write A equals question mark. And once I've got that, the last thing I need to do is the directions. So I like to make positive the direction it's moving. It doesn't matter to me what you pick. You just got to pick something, and you got to show me. Otherwise, I don't know what you pick. In this case, it's moving to the right, so I'm going to make right positive and left negative. All I do is on my acceleration arrow, I put a positive on the side of the arrow that's positive, and a negative on the side of the arrow that's negative. Some people like to always make positive the tip of the arrow and negative the beginning of the arrow. But it doesn't matter. Okay, this is how I did mine. Okay, so I've done all three of the diagram unknowns. Notice I'm not doing a knowns and unknowns chart. I'm not writing knowns and unknowns off to the side. Everything's in the diagram. Okay, like I said, I'm really picky about the diagrams. You got to make sure you have them. So I've got that, and now I'm ready to solve. So find the net force. There's two ways to find the net force. Okay, so A equals F net over M, and F net equals F1 plus F2 plus whatever else there is. So when I'm doing these, I'm asking myself, what do I have? Do I have the acceleration, in which case I use F net over M? Or do I have the forces? Well, in this problem, I have the forces. Okay, I've got FA is 7 and FF is 4. So I'm going to use the F net one. I'm only using the side-to-side forces because that's the direction of the change. So F net equals, it would be FA plus FF. Those are the only two forces acting, so those are the only two forces I include. So when I add them together, I get the applied force is 7, but then friction is in the opposite direction. It's always in the opposite direction. So instead of adding it, I'm going to subtract it because it's taking away, it's not adding to. So I just write minus 4 here. And again, the reason it's negative is because it's in the negative direction. So I just subtract it instead of adding a negative. It's the same either way. And that gives me the net force to be 3 newtons. All right, so there's my net force. Now I need to find what I'm missing. I'm either going to be missing a force, which we'll do in the next one, or we're going to be missing the acceleration. In this case, we're missing the acceleration. So I'm using that other equation, A equals F net over M. Okay, the F net I just found was 3. The mass I had was 3. Gives me an acceleration of 1 meter per second squared, and that's my answer.